these are more ideas from Uncle Bob. He created the solid code principles in late 90s, early 2000s, I think. Published a book about it, and we're going to cover the single responsibility principle. But first, we should talk about software and the value of software. So software has a primary and secondary value. Its secondary value is to behave correctly. Its primary value is to be soft and remain soft over time. And that might seem a little strange to say that the primary value of software is to stay soft, meaning it can be changed, but the secondary value is only to do what it's supposed to do, right? That doesn't make much sense. But think about which is better. A system that meets all the customer's needs today but isn't easy to change, or a system that doesn't meet all the customer's needs today but is easy to change. Because at some point in time, the customer's needs are going to change. So the first system, we can't change it easily, but it does do what we need today, but probably not tomorrow. Whereas the other system doesn't quite get us where we want to be today, but can easily get us there in the future. So hopefully you can see that the latter is better than the former. So Uncle Bob has defined what easy to change code looks like and broken them down into the solid principles. The single responsibility principle, which just says that a module of code should have one responsibility. The open close principle, which says that code should be open to extension but closed to change. The list call substitution principle, which says that any modules of a given type should be substitutable for their base type. So you shouldn't know, if you're looking at an abstract type, that it is this implementation or this implementation. And specifically, you shouldn't be checking for which implementation at runtime you're looking at. Otherwise, you're violating that one. We'll get into these. Interface segregation principle just says to break down types so that way they have separate interfaces, so any client code is only dealing with the most minimal interface necessary, even if the implementation behind the interface is bigger. And the dependency inversion principle is basically saying that rather than going off and creating or accessing the types that you need directly, you should be asking for those types. And so that's typically through a constructor or through a property or a function on the type that you would ask for the dependency and then use it rather than just going directly to it. So those are the solid principles. Today we will be talking about the single responsibility principle. What? No, oops, I jumbled the slides a little bit. My bad. So we can keep the software easy to change, going back a little bit, by being smart about allocating certain functions to certain modules. Okay, now back to where we're supposed to be. Single responsibility principle just says that a module or a class should only have one responsibility. Makes sense. But what is a responsibility? A responsibility is really just a single reason to change. So if there are different reasons to change, those are different responsibilities, right? So how many responsibilities does this employee class have?
None.
None? Calculate.
Say two.
Does that change? I don't see why
No,
it's
a
changed.
reason to change. So if there, what number of reasons are there for it to change?
I'll say two. That's my guess.
Okay. Sam says two, Jess says two.
I think it's one.
One? Okay.
What does describe employee, what's its purpose in life?
To report, like, basically generate a string or something that can describe the employee object or what that employee object represents, or who that employee object.
So we have basically a getter and setter here, understate and describe.
No, so let's assume that this is
Speaking
like,
very broadly.
yeah, I know. So that's why I wanted to let's talk about it. So save here is saving it to the database, basically persisting the object. So describe the employee as somehow generating some view of the employee that some piece of code wants to know what this employee represents, and calculate pay is just calculating some sort of payroll thing.
So, I mean, save
method then has responsibility for getting its internal data into something, in the database, and that something could change.
Right.
So maybe the code in save needs to change.
Yep.
So then that's one responsibility.
Yeah, because that responsibility doesn't affect generating a string about the employee or how the employee gets paid.
Right, but to calculate pay is the other one I was thinking.
Mhm.
The method that to calculate pay could change within the company, whatever, so they have to change how they calculate pay. So those are, I think those are two things, responsibilities that it might need to change.
Yes.
Yeah,
Now-
save isn't unique to that class, probably.
Right.
Other classes, so I
It
wouldn't say
represents
that's
a whole category.
a specific responsibility for that. Well, it's a generic responsibility, I would say, or
Yeah.
something.
So the question is mostly to try to like get down to what you guys are thinking responsibility means, because the definition has a very specific point to what it's getting at. So basically, the responsibilities are who can request the change, and that can be either real people or other systems or whatever. So in this case, the first calculate pay function can have a change requested to it by the payroll system or the payroll people or the stakeholder or whatever.
As in a change in requirements, or?
Yeah, so if there's ever a change in requirements, who is responsible for that?
Right, so then I think that's what I was thinking about,
Yeah.
is that payroll says, oh, we have to now take out extra taxes, so you have to change the way you calculate pay.
Exactly.
The DBA says, oh, we're using the new version of Postgres, so now you have to do something different,
Yeah.
connect differently, or we're implementing some security, so you have to change the way you connect to the database, blah, blah, blah. So now,
Yeah, the third example isn't as clear, but couldn't think of anything. But basically, if you like business operations people just want to go into the employee management system and generate a string that describes the employee so we can put a report out for it or whatever of all of our employees.
now we don't know what skills they have.
Right.
Properties
Voted
could be
to
the
last
training
place.
the employees had, so this
Yeah, sure.
operation could say, who's been trained in Postgres?
Yep. Yeah, exactly. So those are all separate teams or systems within the entire system that could cause a change to the employee class. So therefore, the employee class has 3 responsibilities as defined by Uncle Bob for responsibility.
So therefore, it violates the single responsibility principle.
Correct, because there's 3 stakeholders that could have an effect on the employee object. Okay, so I took a bunch of random notes. As you know, I'm kind of summarizing the videos that, like we saw the intro video, the rest of them all cost money and the company's not gonna pay for it, so I'm summarizing them. So here's some random notes that I couldn't figure out what to do otherwise with. It's a restatement, but it's just that a module should have one and only one reason to change. And their reason to change is basically a change in the requirements. There should only be one category of requirements from one stakeholder that causes this class to change. So when considering how to satisfy the single responsibility principle, it's best to start from the actors and see what kind of behaviors they need from the system. So it's really just looking at the requirements and seeing, okay, does this class apply to different requirements or more than one group of requirements? So different responsibilities change at different times and for different reasons, so they're not always all aligned, and so by having multiple responsibilities in there, you have this like kind of impedance mismatch of when the class needs to be changed and for what reasons. That can cause some release issues and things like that. So we want to gather the things that do change together, and then we want to separate the things that change for different reasons. Okay. Gather what changes for the same reason, separate what changes for different reasons. Another kind of thing to keep in mind is that any class that has multiple responsibilities, you're not going to necessarily see that very clearly. So just going back to here, this is what programmers see, that just a bunch of functions, and it's not entirely obvious that there's 3 different responsibilities going on. So when you're maintaining the class, either you're not familiar with it, or even if you are familiar with it, you might not even notice that there are multiple responsibilities going on.
So better design can lead to better understanding of the code later.
Yeah, and better chance of maintaining it correctly. So if the lines are blurred between the responsibilities, then you may not be respecting them as well when you're making the change. And so you might end up with some function that looks like the thing you need in that module, but it turns out that function's actually for a different responsibility. It just happens to sound like what you're doing. And you know, by the time you ran the code, it worked, and so you check it in, but you don't realize that that call was really doing something else that may be a latent bug that you discover long in the future or something like that, or that becomes the system now, and somehow, I don't know why, but this module A is calling that function on module B, and it really shouldn't, but if we take that out, it's going to break these other things and stuff like that. So if they're all wound together, it's harder to make changes responsibly for the things that need to change. So the other problems are that once you have multiple responsibilities in a module, that module has additional outbound dependencies on the things it needs to do its job. So the more outbound dependencies you have on a class, if another class relies on you, they transitively rely on all the things that you rely on. So you're just kind of growing the problem. Yeah, so anytime that your class changes for responsibility A, you may not care about that. You're just calling it for responsibility B, but now your code has to change because A changed, or that responsibility changed. So you're increasing the frequency of rebuilds, and that might also increase the frequency of retesting or broaden the amount of testing that needs to be done when you're making small changes, kind of late at release or something like that. So it just makes it harder to manage overall. Yeah, it hurts independent deployability. So if we wanted to just make this one little change in a TC or something, it would be best to deploy the smallest bit possible. But if all of the responsibilities are intermixed, it's hard to tease out those changes. And then it's also harder to reuse. So if you have a requirement you're trying to implement and you see a class that kind of does what you need, but it also does 100 other things, it might not be worth bringing in that module because it does all these other things that you would now have to depend on because it depends on those things. Yeah, so Syslus does everything. Do you really want to depend on everything to get that one little part of Syslus? So that's kind of what it looks like. From an implementation standpoint, you have the different libraries or whatever that it depends on, all to satisfy the 3 separate responsibilities for one class. So if you start to look at the bigger picture, you have your whole application and many dependencies into employee for the different responsibilities. And now these classes all up here depend on either changes to those libraries or just a raw dependency at runtime. Like if you were to build just a small part of it to like deploy only this component, you might have to bring these things along even though you don't want to. Okay, so what can we do about that?
I mean, you have to consider something not as just an employee. I mean, you know, the definition of the object, I would think that you'd have to have a payable employee, a savable employee, and a descriptive employee. Or
Okay.
something.
Yeah, so breaking it out into multiple classes.
Yeah.
Okay.
You could just have a single employee class that just knows about the employee, and whenever you need it, you can pass it into another class. Like something that handles saving, a module that handles saving, a module that handles pay calculations.
Okay, so have the dependencies out to the system are proxies to the employee object. Okay. Any other ideas?
You could create an extension framework.
Hey. Okay, so what is the key part of an extension framework?
The fact that the employee doesn't have to depend on the payroll, DBA, or operations directly, but instead they're, yeah, that's where the sentence ended.
Okay.
You need a scene or something, right?
Right. So what makes it so that you don't depend on one to the other in the extension framework? Like what is it about the extension framework that makes that lack of dependency possible?
Yeah.
That was a question.
Yeah, I know.
Okay.
Yeah.
So yeah, a theme such as
You're stretching me.
an interface. So a polymorphic runtime interface, dynamic, whatever, blah, blah, blah. At runtime, an interface can have multiple implementers and you don't know who it is at runtime. So that's one way to do it, is define an interface. So luckily, I think we grabbed all the major ones. Sound good? Any other? No? Okay, moving on. Okay, so let's look at first just defining an interface. That looks a little better. Thoughts?
It looks like more, I can't say it's better.
Yeah.
Okay. Oh, the arrows did not line up. Okay, so can you think of what benefits this gets us?
The dependencies on, like, database API and the other things are now in the info class and not necessarily the employee class.
Right.
So the employee class kind of becomes the interface.
Right. Yeah, that's, by the way, this is a notation that I've come to like where the little angle bracket to I means it's an interface.
Well, it's I.
Rather than,
Is that an I or a vertical bar?
that's an I. Yeah, with the
And
sans
it kind
serif
of
font.
looks like the L next to the employee.
Sorry, lowercase I, or lowercase l, lowercase I, whatever you want. Anyway, so that's the interface. But yes, so the hard dependencies or the concrete dependencies on those implementation details of the database API and the payment gateway or whatever, those are now hidden behind the interface and are only important to the impl class. So we've avoided a lot of the transitive dependency issues that we talked about. What else do you think we might get from this?
Well, I'm thinking you're not really, I mean, you're making it an interface, so things can change underneath in its implementation without affecting the applications that it needs,
Right.
which is like, I think, the big benefit. But you've still got the dependencies on the three things down on the impl class.
Mhm.
So if you make, a change on one of those, because operations need a different string, you change the one thing down in the impl class to meet that,
Right.
then all of the employee impl still has to change.
Right.
So
Yeah, but if operations says that something needs to change, we do have to make a change in the impl.
Oh.
But we've isolated the
So-
propagation of the
Right, the
change.
fan out is only down at that level, not up there. The applications only deal with the employee.
Yeah.
They don't deal directly with the employee impulse, so they don't have the dependencies.
Yeah, so there's no
Transitive.
transitive dependency, there's no need to rebuild every time this changes.
Employee doesn't care how described employee works.
Right.
Right.
Right, yeah, so we're just saying what an employee looks like, but not necessarily how it's implemented, at least according to the build system and things like that. So what don't we get out of this?
Separation of the three areas. I mean,
Right.
they're all still on the employee.
Yeah, so changes to the interface still affect all actors.
Right.
So an actor from payroll, if describe employee changes, the interface changes, so that change still propagates. So we reduce the frequency because now we can at least change the implementation safely, but we're still not helping with the change to the interface because one would assume at least if a given actor asked for a change, it's fair that that would cause some sort of like ripple effect of rebuilding or whatever, or changes to the code.
To him.
To that actor, but it should not affect the others as well. At best case, a change to the definition of calculate pay wouldn't cause code to change in the DBA or operations actors, but it would at least probably cause a rebuild, and if you want to really make sure you're testing all your stuff, that would be a retest. So, let's make sure I've got all this. Users, yeah, so we're no longer coupled to the implementation, but we still are subject to changes in the interface. So we could have proxy classes. And now the payroll actor is only looking at the employee gateway. Whoops. Sorry, I did that wrong. Swap those two. So the payroll actor is only looking at the employee pay calculator class. And the DBA is looking at the employee database gateway. And the operations is looking at employee reporter. And now employee kind of just becomes this like sort of data structure with maybe some minimal implementations that aren't so much, are more application specific than they are business responsibility specific. So they all depend that way.
How do you combine that with the impl? I mean, making an interface and have an implementation class. Do each three guys get an implementation class? Or only
Yeah, these are all just three concrete implementations. So, but the thing is that the dependency is only from, like payroll only depends on changes to employee gateway, and the changes necessary for payroll, sorry. So the changes necessary for payroll only exist in here, so that won't have an effect on the data structure.
So this is an alternative to the previous slide.
Yeah, we're just going over different options. So like, what can we do about the original problem? So, this thing, like, what can we do? And breaking up a single interface was one option, and now this is another. So, we've gained some things, right? Changes from one responsibility or one actor only affect one class, and we've really moved out anything that's specific to the actors into separate classes. So there's less need to change here, most likely. Any downsides to this?
It does still seem like that data, the employee data is a point of contention, especially
Mhm.
given that it's often defined in a way that's similar to what's in the database.
Right.
So the DBA could require a change that ultimately makes all of those modules need to change how they look at employee data.
Yep. Yeah, they are a flattening, and it's possible that you could have things that are specific to the data structures, the data structure for the database in the gateway object, so that maybe like the modified time or like the primary key values or whatever, those could go in the gateway, and only like not so much specific to the database would be in that structure, but it's possible that that could leak in, yeah. Any other downsides?
Well, if those three are all concrete implementations, then you don't have the benefit of the previous slide where you've made an interface change so that the applications are independent of the implementation. So if you change something in one of these three,
Mhm.
then all the applications
Right.
still have to change.
Yeah, and so,
They could affect the employee data.
yeah, so each one of those proxy classes, its implementation is still concrete.
We could
So,
fix that though simply by defining interface for the proxy classes.
yeah, so you could turtles all the way down and make
Right.
an interface for each to isolate out the implementation. I think that, there's one important thing that we are missing out of this implementation. Where did employee go? We have a domain concept of employee. We have employees in the company.
Right.
Where in the code is the employee class?
But does there have to be in the code one employee? I mean,
There doesn't have to be,
you
but
have an employee that has different meanings to different actors, right? I mean,
Right.
the different.
But you still need a way of identifying the employee, like by ID or by name or whatever. There still needs to be a mapping from each one of those to the employee data, which is where the
Right.
concept of the employee is.
yeah, so
Can you make an abstract employee class?
you could, but what's gonna go in it, and what behavior do we have? And like, does the abstract employee guy contain this entire thing, only part of it? Like, what benefit are we getting from having it?
Well, is the employee then just where you have employee data, that could be the employee that has the common information and then has the interfaces to these other three things that are the seams or whatever.
Yeah. Yeah, so there's strategies you can do. It's just mostly trying to emphasize that we did lose the single idea of an employee, which is part of our domain, and the code should really be as close to the domain as possible. Another thing is, if you imagine either a new programmer or someone who just hasn't dealt with the employee part of our application, that they go to look for the employee code, and where it's scattered everywhere, right?
Right.
So it's hard to tell, maybe when you're off as a programmer in the details of the application, where am I to go to make a change that I need according to this requirements spec in TFS or whatever. So it can be harder to hunt down, it's less discoverable for the programmers, but it's not really a problem for the end system.
But is that just a trade-off of understandability, maintainability versus this?
Right,
You
yeah.
know, it's just, you're not gonna be able, there's no solution that's but good for everybody.
Mhm.
You know, because you want just one employee, because you want, like if you're learning the code or maintaining the code, you want one employee, that helps you.
Right.
But one employee doesn't help with the dependencies, the fan out, and
Yep.
the other stuff. So it's like, oh, which which way do you go?
Right, yeah, so it's just something to have to consider. We're back to transitive dependencies, although it's kind of broken up now. You have the employee gateway will have a database API dependency, but anyone who doesn't care about the employee gateway won't need to depend on it. And yeah, so, and then I mentioned it's more difficult for programmers to discover what the whole of employee looks like. So there's another one where we can build a facade. So now we're back to our single employee object, and the actual implementations of each responsibility are broken up, so that way the chances of needing a change to employee reporter won't actually change the employee implementation. And with Sam's point from the last slide, we could kind of combine the first solution by plopping an interface on top. And now any change to the concrete implementations won't affect the interface, but the main or the interface is implemented by a single employee class. So now we have a better idea in the code. Okay, I need to change something with the employee. I'll go open up the employee class. Oh, that's just deferring to all of these others. So it's a facade where it's not actually doing the work. It's just breaking it out into the other classes.
You go to Walmart or something, because you know, all right, I'm gonna go to Walmart. Then there's different departments in Walmart, then you go to there to get the individual things.
Yeah.
You don't have to know, it's not hidden in some back alley shop somewhere.
Yep. So, any communal thoughts on this?
Knowing when to do which, when do you have a facade, when do you put in an interface, when do you do actual other implementations. I mean, there's several different techniques there, and then it's just gonna do, learning, well, when would it be good to do this, and when would it not?
Yep. But what it, thoughts specifically on the benefits or cons of this approach?
And the facade.
Yeah.
It's a lot more readable. If you're just jumping into the code, it's easier just to look at and see, oh, this is where this is done, this is where this is done.
Right.
If they share something, if I would be concerned that things would get duplicated in this, and you'd have to change things in the employee reporter, the employee pay calculator, and the employee gateway,
Yeah,
instead of just
yeah.
one particular place,
Yep.
which then increases maintenance.
That's usually a code smell of the single responsibility principle being violated.
Right.
So yeah, I mean, you can attempt to solve or to not violate the SRP and then accidentally start leaking the violations back in. That would just hopefully be a cue to someone to go and clean it up a little bit more.
Right.
Either move things into the facade, because the facade doesn't have to be 100% dispatched to its implementations, but the different parts of it should be, and then if there are commonalities, then they should be in the facade object. So. All right, anything else? Pros, cons?
I guess I'm just curious, as you have that drawing, I mean, the employee reporter, that could simply be the logic that's inside the described employee method.
Right. That's the whole thing. Is a facade is just a simple object that is simplifying a more complicated interface. It's a design pattern. We can go over patterns
It's
eventually.
bringing it closer to the design or the domain, problem domain.
Yeah. So this is sort of the proxy classes solution, but we gain the discoverability of the code by wrapping it into a single facade. There can also be other benefits because you can build different facades for different reasons to simplify different things. So if you needed a version of employee that for some reason the code needed to branch off only two of the responsibilities, you could do that, and then just because of the way that the code needed it to be that way, you couldn't break them all out, you could at least make a different facade to sort of isolate the problem. But yeah, so most of the implementation of the facade is really in each of the concrete classes.
But, okay, I think your point was that the employee reporter could be so simple that it's just in describe employee.
Oh, is that-
facade.
Yeah, well, I guess I'm just viewing this as basically drawing a class with methods, I mean,
Yeah.
that's what you've drawn, I mean, you can
That's,
You give it other
that's how
names.
I've seen it.
Well, so
You
in-
just flipped it all around to the original, and
Yeah.
you've just given those boxes names. I
Right.
mean,
Yeah, but so, okay, keep in mind though, this is like incredibly simplified example.
correct.
So there could be 15 to 20 or 30 functions here, and there could only be 3 responsibilities. So the grouping will be broken down, so this could be 5 or 6 functions, and this could be 2 or 3 functions, and so on.
Okay.
Employee might just have an
Right.
employee reporter object and it does all the nonsense it needs to do
Yeah.
in its own bit.
Right.
But what you just described in a more complex case, I mean, but you're making the distinction between public methods and private methods. The 3 things that are exposed are the public methods, and if there's 50 that are required to do employee reporting, they're private methods.
Right, but if we get back to the point made earlier that if all of the implementation is just lobbed into a single class, it's not well defined where those responsibilities are. So maybe when the author who first wrote the class knew what those responsibilities were and didn't really worry about the fact that these things might be confusing, a new developer might come in and not know what all of the responsibilities of the class are and realize that there's 10 things that are specific to operations and 5 to payroll and 2 to the database or something. And they might start mixing and matching or making additional functions that are now kind of blending the colors together in a way that was never intended. So it can hurt in maintenance to just have everything in one class. So yeah, you're not getting a lot by doing this other than defining this is the part that's specific for the operations actor, and this is the part that's specific to payroll, and this is the part that's specific for the database.
In part, all this really does is just modularization of code, but that
Yeah.
really helps maintainability.
Yeah, and if, again with Sam's point with the interfaces, if you put an interface between these layers, then now you can change the implementation or deploy the implementation independently of the facade. So there are other ways to scramble this around to make it a little bit more beneficial, so that the employee facade is only holding an employee reporter interface and an employee pay calculator interface. And now you can deploy a employee pay calculator.dll and only change that one DLL and have the behavior of the employee facade take that change and run with it without having to deploy all the other DLLs. So there's lots of ways to again, jumble this up to get different benefits.
Right. I mean, you go back to a facade where you now put all the the methods back in the one thing. It's more discoverable, understandable, etc. But then now you're tying it into the applications that then use that.
Mhm.
If there's a change in the payroll that needs another method, then boom, this thing and the facade has to change so that they can get access to it.
Right.
So if you change the facade, then everybody has to rebuild.
Yep. Yeah, and if we go with the example that there were interfaces here, then you still have the same thing where we've isolated the implementation, but changes to the interface mean change to the facade, which means a change to all dependencies, or inbound dependencies. Yeah, so you still have some problems and some benefits. So,
But I mean, that's, I guess, what you're describing, I mean, that's what encapsulation is. I mean, encapsulation is having, I mean, describe employee is a method on an interface that has a specific set of requirements, and you can change the implementation of how that's done. I guess I'm not sure how that's going to have an adverse effect on calculate pay. I mean, there may be, certainly, if we're talking about
I mean, it won't
reducing build time, I mean, that's another goal.
Right,
But
because I mean, if you have a change in the requirement for describe employee, whatever, you can change an implementation in employee reporter without it affecting anything else. But if you've changed, the requirement is changed so that the interface has to change, the employee, they need to describe employee's spouse or something. I don't know, then you've now changed the interface in the facade, which means anybody else using that facade has to at least rebuild.
Oh, yeah, no, that's what I was saying.
the build issue isn't so much the build times, it's the idea of independent deployability and the isolation of test effort. So if you have a private section of a class in C++, however, if you change that private implementation, are the callers of your class protected from that change? No, they still depend on your DLL. So if you isolate it out to an interface, then now the facade is in a separate component, and the implementations are in yet another separate component, and the implementations of the facade can change independently of the modules that, or of the components that contain the facade itself. So you don't get that sort of build time encapsulation with C++ or Java or C#.
Well, I guess I mean, you can reduce what you the build dependencies through the interface. I mean, that's what you can do.
Yeah, that's just another strategy. Yeah, this is just one option, and if you need certain benefits that we have, you know, interfaces for this thing or whatever, then you go a different way, but this is just one option.
That's where you get the trade-offs. I mean, is the maintainability in a single facade more important for later use?
Right.
Or do you need to, did things change so often in the interface for one responsibility that you're like, okay, we gotta separate that out?
Yeah, exactly. I mean, each one of these slides has a pro and a con that I've just boiled down to 2 lines. So I'm not saying that this is, any of these are perfect solutions.
Oh, I understand that. I mean,
So, users in the module are back to being affected by changes to all responsibilities because we have the concrete implementations, but we had mentioned we can break out interfaces between the implementations of the facade to kind of protect against that. And now it's easier for the programmers to kind of figure out the starting point of an employee and where that breaks down. And apparently PowerPoint was really cool and knew that facade has a fancy C. Okay.
I was gonna say, hey, good job for putting this idea.
Yeah, no, I did that for me. Okay, so then an additional option is to break out more than one interface. And so now each interface is defined by the needs of the actor. So we have the employee gateway interface, the employee pay calculator interface, and the employee reporter interface. And I still got those all backwards. This is what happens when you copy and paste. So now you have an implementation that could have all these things together because it's just the easiest way to implement them. When you're writing the code, it's just nice to have this all together. There might be some commonalities between the 2 responsibilities that you just, it's easier to keep all the things in one place. But all of the users of this implementation only see the interface. And if you could guess by the name of the I principle in Solid for interface segregation principle, this is an implementation of interface segregation, where you now break down a smaller interface from a larger class.
But you still have a common piece for maintainability, discoverability. You know, I need to do something with employees. Well, start there.
Right. Yep. So ideally, as long as, or if the interface here changes, then that changes the implementation, but the employee gateway interface users are only looking at this interface. So they have no idea that the green and blue functions even exist in the implementation. And so if the employee reporter interface changes, then it has no idea, the users of the interface have no idea that the red and green implementations exist. So we can continue to change the implementation and be kind of protected behind the individual interfaces.
But it immediately makes me think of like working effectively with legacy code, things we could do with like Composer. I mean, you could take syslist or sysview or whatever, and they become the info classes, and then you add on interface classes on top of that, so that then you get in there, the actors that were using those things then start using interfaces, and you change out underneath it to make it a better thing over time.
Yep. Yeah, no, that is actually one of the techniques, is to extract interface. And then now clients are looking at a more minimal definition of the class. And the nice thing is because you're hiding behind what you could effectively call a compiler firewall provided by the interfaces, no one knows about that implementation anymore. And so you can start to do other things on the other side, such as break the class apart and all that.
well, that, I mean, not to mention the devil, but I mean, that's exactly COM.
Yeah, it's interfaces.
Yeah.
Yeah.
I mean, it's precisely COM. And you do have an impl that has many interfaces, and quite often you just get the one interface, the individual clients.
Yep. Yeah, I mean, there's nothing to say in this diagram, it's completely agnostic, those could all be common interfaces.
No, I'm just saying it's following that model. I'm not, no, I actually like the idea of defining the interfaces. There was a very interesting problem Sean helped me solve a couple of years ago by basically defining just, and it was to solve a linking problem. We were never, ever going to link because this guy who built at the very end, and it was dependent on the guy who built very early, and it just was all solved by defining the interface, and then basically the guy who needed to invoke methods on the interface didn't even know or link against the implementer of it.
Mhm. Yep.
So it's not like I'm a big advocate of COM.
Not at all.
I'm just saying that some of the principles talking more generally, are a good thing. And I think that's what you're showing me there.
Yeah, definitely. Yeah, I mean, breaking down things into smaller interfaces can have a huge benefit. So, each interface. Okay, so I think I touched on that. Interface change only for that responsibility. I think I also mentioned that. And that the one downside that I could think of anyway was that, and maybe I should have asked, but if you're in the code on the right-hand side, imagine a big cloud of code over there where the smiley faces are, and you're only looking at an employee gateway. When you have the code, you see that you're holding an employee gateway object, but now you want to know what to do to change it, because, okay, if there's a bug there or something, I need to change the employee gateway, but then you find out it's an interface, and now you have to go hunting some more to figure out who all implements it, and okay, in that one case that I saw this bug, was it this implementation or that implementation? So it's a minor downside, I think, but especially if the debugger can tell you at runtime what you're actually looking at. So that's why I put this statically here, that when you're just looking at the code, it's a lot harder to know who is who and whatever, but there are ways to figure it out.
I sort of had a question. When you're using the phrase something like responsible for change, that the concrete example is payroll has a different requirement than it did before. That's the change. Its
Right.
requirement, so, okay.
Yeah, so when I first learned about the single responsibility principle, to me, the responsibilities of a class were just defined inwardly by what it does. But in reality, that would just kind of come out to, okay, well, all classes have to have one function, and that function can only do one and one thing only, right? So those aren't very useful classes. But if you think about it in terms of the requirements or the stakeholders of the application and just trying to keep their needs separated within the code itself, then the code is going to be easier to change because you've got everything laid out the way that you would expect.
Yeah, what you first stated was the exact confusion I was having at first. How
Yeah.
you were, but I now get it. The clients, the actors are the ones that provide the change requirement.
Right.
And it's the single responsibility principle that may not really apply down at the employee input level. When we originally saw employee, he's got multiple responsibilities, so how do you break it up? Well, it's more like the actors that you're dealing with, the objects that they see, have a single responsibility.
Yeah, and that's part of the whole trade-off thing, right? That you might have a class that does represent the implementation of multiple responsibilities, but maybe you can do something to where, like I mentioned, it might be convenient to implement it that way. That it's just the easiest way to keep that bit of code together, because then I can do this thing easier. But you don't want to make that little piece of code that's easier to write that way hold the rest of the system hostage. And so there are different ways of doing that, and one of them is to break out different interfaces. So now they all just look like little classes when they're actually implemented as one big class. Okay, so what's the ultimate answer according to Uncle Bob?
It depends.
I was gonna say.
there isn't one. Welcome to engineering. So, yeah, you just have to weigh the trade-offs of each of the solutions. There are, I mean, we saw the fact that those were the different proposed ways of fixing it, but you could even jumble each one of them up and add interfaces here or there or whatever. So there's lots of different options. It's kind of a design consideration, engineering problem. There's no great way to solve all of the issues with single responsibility violations. You just kind of have to play it by ear.
There's no, what do they call it, guide to being correct or whatever, where you shall do this. You
Right.
can't just look at it and say, oh, you did this, that's wrong, you have to do it this way.
Yeah, and that's why these are principles. Like, the idea is not that these things have solutions. What's that?
Rubric, just remember the word I was searching.
Oh, okay, yeah, yeah. Yeah, there's no rubric for following solutions to these things. They're all descriptions of kind of fuzzy problems with different fuzzy ways of solving them that have trade-offs. So you just have to take what options are there and consider, okay, well, this particular component doesn't actually have a lot of inbound dependencies. It turns out that giant fuzzy cloud of the rest of the application is fairly small. And so that might mean that one option is more preferable over the other because, yeah, it causes a concrete dependency into maybe the facade, but there are so few inbound dependencies into that facade that changes to it really don't affect that much. Or you know that, at least today, the inbound dependencies are all isolated to one component, and that component kind of shares a relationship and things like that. So,
It's engineering, there's trade-offs, there's different ways of doing things. And then when you're making when you're doing something, implementing it, you're making choices. You have reasoning that goes in behind those choices.
Yeah.
Like you were just saying, the fan in or whatever, come on. Should that be documented somewhere so that people later on, or you, can remember or discover why it was done a certain way?
it's not the worst idea, I just don't know if it matters. Sometimes it might take more time to worry about that than it does to just fix it, and that will go into later talks about how to, take one solution and turn it into another. That you just sort of respect the fact that there must have been some reason for this, but now the reasons have changed, and we can change them. One documentation point could just be automated tests around it to exemplify different problems or something. It's hard to exemplify build dependencies and things in a test, but get the idea from there.
But automated testing is a good answer, but, yeah. I'm just thinking of, you're trying to figure out, you get some new code, you're responsible now to fix this bug, and you're looking at it, and it's like, why is it doing it this way?
Yeah.
And I hear an awful lot, because we get a lot of people new to Composer, relatively, it's just, why the hell was it done this way? You guys are idiots, It's like, well, there were reasons, and then some of them might be in some comments that have brought it away and, don't really help it. It would be nice if the decisions you've made on your design choices were documented somewhere, so that you could convey them somewhere.
Some people are big proponents of documenting the reasoning for a decision rather than the decision itself, rather than making a giant architecture diagram with fancy UML, just saying why you did the things that you did. And of course it gets out of date in the same way that everything else does. And all it does is provide you with a warm, fuzzy feeling of when you deviate from that document, now you know at least why you're deviating from it. So, who knows?
Yeah, that made me think of a good point that when you're making the change, especially if it's something weird, you have a system, we all have a system right now that would give us a chance to document that.
Commit change.
Right, yeah. So when you're checking in the code, explain, maybe this is weird, I should explain why. And then
That's fine.
if someone is asking the question, why was it done this way, the first reaction should be to go and hit right-click on the file, go to source control, annotate. Or if you're in Git, it'll say blame, same feature. And it will now break out line by line. It will show you all the change sets associated to each line that you're looking at. You can scroll through the file, and it'll show you the change sets. And now you can hover over that left-hand pane and see the descriptions of why this code is the way it is. And that might at least give you the most recent explanation, but then you can check the history and get a little bit more of a context.
Yeah.
And now it doesn't necessarily rot over time because that is the exact documentation at that time.
Right. And that's good, you know, it's just, for our situation, it's a little limited because it's TFS and Git are newer. You have to go
Yeah,
back
you
to-
just have to get familiar with the tools.
You have to go back to spelunking into the old composer source set.
Yeah, and obviously, right, it only goes back so far, but.
Yeah. Well, it's the difference in your check-in comment before describing what you changed, which a diff does, as opposed to why you changed.
Exactly.
Right.
Yeah, the comments in a change set are much more useful when it says why you did something than what you did.
Yeah.
Exactly, yeah, and the
I'm
diff,
bad at that.
I mean, the diff is great, you
Or-
can see it, but then you see the guy back, you know.
Yeah, I mean, more emphasis should be spent on commenting the weird parts, like, you might not realize I did it this way because of these other things going on today.
And if you do this in the future, look out for this.
Right.
As opposed to just having something in the code that says, don't change this, not sure why.
Yeah.
And the
Or
change
it's
sets,
changed, right, here be dragons.
the change set comments will make you happy, Brett, it will not clutter the code, and yet you can find that information.
I would hope it would make everyone happy, but yeah, sure.
Well, particularly you just, seem to become rather vehement when you see green.
I fixed that on my machine, I just made comments invisible.
Well, that's good,
Problem solved.
that's good. Yeah.
No, not so much green on my screen anymore.
Yeah.
Well, the only reason, I mean, the reason you are sad by comments is because they rot.
Yeah, exactly. It's very rare to come across a comment in my experience that was useful. They just, oh, okay, either it's in the wrong line, or it doesn't apply anymore, or it says temporary fix that was checked in 25 years ago. So it's
Wait,
like,
whoa, wait a
whatever.
minute. Why is the comment in the code any different than the comments on the check-in as to why the code changed?
Because the check-in comments don't rot, the comments do. The comment can be moved around in the code. It can no longer apply because someone either didn't realize that that comment applied to the piece of code that was 15 lines below, and now the comment no longer makes sense to the code that was changed 10 years after the comment was made.
Okay, but how does the comment on the check-in not rot when you're 15 check-ins later?
Because the source control system maps the state of the code with that comment. So you can change the code, and the original comment and the original state of the code never go out of
Yeah,
line.
okay, so if you're going from 15 revisions ago to 14 revisions ago, you see what the changes made at that time, and that doesn't rot, I give you
Yeah.
that.
No, I think you're.
Also, a lot more work to fish your way through that than to be reading the code, seeing something, and seeing a very key comment as to why something was done at this time.
If you haven't
I
been
do
trained,
agree
you
that
completely
it
ignore it.
can rot, but if it's a key comment about a key decision,
That's the important
it's
part.
more likely not to rot.
If only comments only were key things about key things, that comment because I like it this way, or comment temporary fix from 20 years ago, or comment this
Sure,
is the
Sure, the to-do,
input
temporary
parameter
fix,
name,
yeah,
blah,
those
blah,
are
blah.
worthless.
Yeah.
I agree.
Yeah.
Well, and you object to the ones that, Practice 3482, which
Yeah.
is 15 years old, you can't even easily find the Practice.
Yeah.
And then there's like a whole paragraph, which is relevant, by the way, but it just, at some point, you affect the readability of the code. It's just like conditional code.
Yeah. Yeah,
Conditional
no.
code's very handy, but if you have a lot of conditional code, it goes from handy to annoying.
I will defend myself only to say there are instances where I pointed out to you good comments, right?
Yeah.
Yeah. So I do also bash on a lot of bad ones, but there are times where I go, wow, that's actually a good one.
I don't know if
And-
that's 50-50, but yeah, you do
No.
occasionally.
The problem though is that not 50-50, because most of the time comments are bad. Uncle Bob says that you should make the comments on your editor bright red, because that gets your attention. And the fact that there are so many useless comments in the code bases I've worked in that you don't want to make it bright red, because then it's just constantly screaming at you all the time, isn't helpful. You should be surprised to see a comment, and there should be a good reason for that comment, and that comment should be as close to the problem code as possible, and even maybe on the end of the line, so it stays with it at all times, that kind of thing. But that's a whole
To try and-
unrelated discussion.
Oh, I know, I
And
just,
that's
I think
the
the
truth
key
of
is
comment.
Yes,
That's to keep the
Think I'm
comment
good to
being
go.
key, right,
Mhm.
and being applicable. I mean,
I tend not to write any comments, so.
Yeah, I mean,
That's
it's-
not true.
Oh, no, you write them, Dave.
You absolutely. do.
Oh,
Yeah.
Bad ones.
No, I would say they're good ones, but that's opinion. I mean,
Anything on single responsibility principle?
well, I just tossed that out, that's
yeah,
fine.
and it's good
No, it's very good.
to get experience with it.
Yeah, yeah, I mean, it mostly helps to know what sort of strategies other people have considered, and so that's why they were spelled out. And then know that you can kind of remix them however you want that applies to your situation. And also to know that none of them are the perfect solution.
It's
So you do
engineering.
have to consider it.
It's engineering, it's trade-offs, it's right tool for the right job.
Yep.